All right, guys. Welcome for joining us today. We're going to be talking about two topics. The first one is already on the screen, data visualization. And the second one will be data literacy. So we're going to talk about those two training and the material that's supporting that. But before we jump into the training itself, I'd like to start off with introducing the Effective Data Foundation. The Effective Data Foundation is trying to help professionals to leverage their data. That's the basic idea, because in the end, we want to do something with that data. And in the Effective Data Foundation, we have developed a number of training sessions that focus on a specific need. And if I have to summarize them all, then basically this is the summary. Yeah? So we talk about data visualization. So how do we bring the data to a human audience? Data literacy. How do you process data? Do we understand data? I don't know about you, but I hear a lot of people talking that they are working for an organization that sees themselves as a data-driven organization. What does that mean, data-driven? And those kind of things. So we'll look at that in data literacy. And finally, data management. You might be aware there's a DAMA organization, the Data Management Association, and they develop exams to certify in data management. And they have a very clear description on the fundamentals exams, but there's also specialty exams. And those are less described, and therefore we took the challenge to develop those trainings. So we are developing a number of these specialty exams for the DAMA Association. But hey, enough about the Effective Data Foundation. Why am I talking right now? Well, the thing is that in 2007, I decided to quit my job. And I thought, why am I doing the things I'm doing? And I've been working all my working life in data. And I was wondering, why do the things that I built, in general, these were reports and dashboards and those things, why do they look the way they look? And why is on it, why is the content that I put on it, why is it there? Who decided that? And those are the two questions that still keep me busy every day. And in 2011, I decided to start actually delivering it in training sessions, because people asked me for that. And as said earlier on, every time people ask me, are you a trainer? I always tell them, no, that's just a part-time thing I do. But as you can see here, it's always a couple of years that I do 50 plus trainings every year. And this year even beyond 60. So maybe part-time train is not the right term anymore. And besides the training, giving the training, I also developed the material and everything around it. But okay, let's dive into the content. Enough about the Effective Data Foundation. And the biggest challenge I have a lot of times is that people associate data visualization with a technology challenge. And they see the term data and they say, oh, wait a minute, I need to do something with a computer, or even people that say, oh, no, I don't want to do this because this sounds technical. But the funny thing is, data visualization has nothing to do with technology. Obviously, we're going to implement it in some kind of technology, but the decisions that we make, how does the report or the dashboard or the visualization look like, has nothing to do with the technology, but everything to do with design. So we need to optimize these data products for human consumption, and therefore we need to see how do people process visual information. And that's the basic idea behind this training, is that we're going to focus on how do we human beings process visual information, and how can we make use of that knowledge to optimize these products. Because most of you probably have seen lots of reports and dashboards around you. And a lot of times when I see all these reports and dashboards, I ask myself the question, is this really built for human consumption? Well, you might think about a couple of reports you saw lately, but a lot of them don't fall into the category of ready for human consumption. So why do we visualize data? Well, the first thing there, and again, this is how I look at it. I understand there's different views on this, but the first thing there is to facilitate understanding. We want to learn something from our data. We want to see what the data is trying to tell us so that we can, in the end, act on it. This is the real value of data, is being able to act on it. Sometimes I hear people say, no, the goal of data is insight. Well, insight is like running a marathon and then 100 meters before the finish stopping. Eh? It's a shame. Only insight. Oh, and I know everything. No, no, no. You don't want to do insight. You want to act. The moment you got act on it is when the real value kicks in. And the visual form basically allows you to make use of this great phenomena that we human beings have. We are very good at identifying, comparing patterns, trends, and deviations from that, or call them outliers. So, and this is why we basically visualize data. And I'll show you an example later on why tables alone are probably not going to make it. For who is this training actually built? Well, the training is built for anyone who is involved in creating data visualizations. It doesn't have to be the person that really builds them. It can also be the analyst or the business consultant that is the intermediate between the users and the builders. But anyone who's involved there and wants to build these things or design these things for a specific audience, this is actually what this training is built for. And also to give you some background, the training already exists in 2015. There have been some permutations in that time, but it has already been attended by more than 1,000 students. So it's not like it's a fresh built new training. And although there's obvious always changes being applied through time, it's still results in the same reactions that we had initially, and that's that people really like the other view on how to do this. I also warn students before they start attending the training that after the training they probably will never ever look at a chart in a normal way anymore. That's the downside of this training. You can't. Hopefully the trainer will not have that much impact, but I cannot guarantee you that. So beware. And then the next thing is, okay, how is this training built up? Well, here you have the rough agenda of the training. So obviously we do some introduction and we talk about the history, where does it come from and how can we apply it? And then very early in the training, we jump into the human perception part. Because if we want to make data visualization work for us humans, we need to understand how human perception, how human visual perception works. And we're not going to talk about all the other perception types, but human visual perception is the one that we're going to highlight there. And then afterwards, we're going to see how we can use that in visualizing data. And then we're going to look at things like, well, which chart types do we actually have? And when should we use which one? This is then the overview. And then afterwards, we're going to go into the design. There's lots of things within visualizations that need attention. Titles, labels, markers, elements, lines, grid lines, you name it. And those are the things that we're going to look into detail in data viz design, including font types. When do you use what? How do you build a good table? Those kind of things. Then a lot of times people will also use these visualizations in a broader perspective, call it a story or a narrative. And that's what we're going to do in this section. And then finally, at the end of the training, we're also going to look at the workflow and the approach. What do you do with it? How do you approach it? How do you get this to work? And the agenda, the rough agenda you see here is a 2-day training. So roughly the left-hand side is the first day and the right-hand side is the second day. The split is not that clear, but that's roughly it. So it's a 7-hour-a-day instructor-led training. That's where it's built up. And I was almost going to say, obviously, at least I think it's obvious, is that it's not only sending knowledge out, but it's also actively applying it. So in each of these chapters, there's actually also all kind of exercises that the attendees need to work on, where they actually can practice what they had just learned. I don't know how much you already heard about these trainings, but there's also an exam, certification exam, and these topics all have their own weight in that exam, and here you see an overview of the weight of each of the topics. So as you can see, visualizing data is the prime topic, followed by the design and human perception. Then we have storytelling, and workflow also plays 10% part of all the questions that you'll encounter in the certification exam. So what does the training consist of? So if you look at it from a trainer perspective, well, first of all, we obviously have slides. And each of the slides have speaker notes. And the speaker notes clearly state what the objective of the slide is and what the narrative should be. Again, every trainer is free to do their own version of it, but everything is there. So you have the objective, you have the narratives, you have the explanation, and also the standard exercises. The exercises also contain a description of what we're trying to achieve by giving that exercise, because maybe in your own surroundings, or maybe for the people you're doing the training, you also have other material. Every now and then, especially when it's an in-house training at an organization, they want to use their own material. I'm not always happy to do so, because sometimes you get into discussions that don't belong in your training but should belong in some other room. But if you do so, it's very handy that the exercises also contain some description of what we're trying to achieve there, so you can replace them with your own material or the material of your customer. There's also a separate handout for the participants. The handout, I tend to give it to the participants after the training, so not during the training. Some people don't like that, because they say, oh no, why can't you give it up front, and then I don't have to write that much. As you can see, I'm not the youngest person. I'm old school, and I think that if you write and you take notes, you learn better. So we tell the story, we do the exercises, and after the training, I send these handouts to the participants. And again, that's my choice. Hey, how you do it, that's up to you. But for me, it works very well to keep those handouts at the end. Give them after the training, so people have like a small booklet where they can actually look up and find some new things. And also, this will help them to prepare for the exam. And then obviously, as already mentioned, there is also the certification exam. And if you have an certification exam, you also need to have a form that tells you that you actually achieved it. And so here you see Marley Buitenhuis. She's actually literally the first person ever who actually certified in one go. She did it. So very proud of her that she got this. And what does the exam actually mean? Well, the exam consists out of 60 multiple choice questions. You have an hour time, and you need to pass at least 65% of all the questions. So if you have 65% of the questions right, within 60 minutes, you'll pass and you'll have your certification there. Okay. Hey, enough about the approach. I would like to dive into some of the content. Any questions so far?
I like how you visualize the data.
Very good, thank you. Okay, well, if there's no questions, let's dive into the content itself. So as said, the training starts with an introduction, but that's not new. A lot of training start with an introduction. And let me show you briefly what's in there. First of all, although sometimes I hear people saying, oh, this is a really hot topic, it's not new. We have been visualizing data for centuries already, and it's absolutely good to have a look at what other people did way back when. So that's one thing that we are going to look at. And although today we're not going to talk about a lot about it, but there's this very famous guy who actually invented the line, the bar, and the pie chart. And it would be a shame if we wouldn't give him a podium to talk about that. But we'll look about the brief history right away. Then we also need to address this question: why do we actually visualize data? And again, I'll address that right away. And I don't know if you all will get excited, but if we talk about data, we also need to learn a little bit about the data dynamics itself. So what does data do and what doesn't it do? Because some of these things we can, and some other things we can't fix within the visualization part. So we have a look at that as well. So let's have a look at this history. So we go through history, and this is one of the oldest I tend to use. This is from 1644. So this is old. Some people call me old. This is really old. 1644. That's ages ago. And this was actually built at the Spanish court because they wanted to know the distance between Toledo, a city in Spain, and Rome, a city in Italy. Very important commercial relation between these two cities. And in these days, they were very fond of expressing distance in longitudes. I prefer kilometers, but again, they did it in this way. But you can imagine in those days, they didn't have all the sophisticated tools that we have today. So there was a lot of discussion about how far is it really? How far is it from Toledo to Rome? And so they asked all kind of experts, and all these little puppets here on this scale, these are all experts with their name, you see. And you see that the one who thinks that the distance is not really that far says, well, it's just below 18 grades of longitude. But the one who is most skeptical says, no, it's just beyond 30. Whoever is right, there's a huge space between these two estimates. By the way, this very modern looking arrow is not part of this visual. This is actually the real distance if you would measure it with our tools today. So everybody was exaggerating the distance there.
Sorry, what is a longitude? Is that just a metric?
Yeah. So like a latitude and longitude, like you do coordinates on a map. Every latitude or every longitude is a distance. Yeah, I don't remember exactly how much kilometers it is, but I know that the distance from Toledo to Rome is about 2,000 kilometers. So I don't know how this calculation works there.
Yeah.
But the most funny thing about this visualization actually is that before this time, before 1644, most of the visualizations were concrete, were things you would encounter in life. People, animals, houses, those kind of things. And here suddenly somebody decides to draw a straight line between Toledo and Rome. And anyone can understand there is no straight line between Toledo and Rome. Well, you could draw it nowadays, but you'll get wet feet. There's water in between. So if you're going to travel from Toledo to Rome, there is never, ever a straight line. So this is an abstraction. And this is actually the start of abstractions in data visualizations. And let's be honest, most of our visualizations are abstractions. So here's when the fun part starts. Now we're kicking it off. So 1644, it's Michael Florent who actually started doing this. Obviously, in the training, we also look at the development through time, and we go to the 17th century and the 18th, etc. But for today, I'll leave you with this one. By the way, a question to you in the training. Do you know who actually invented the line and the bar chart and the pie chart for us? Any idea, Tato, Yolanda?
No clue.
It's a shame, So these are the most popular charts that we have, and nobody knows the guy's name. It's actually William Playfair. William Playfair is the inventor, and he's from Scotland. And besides building visualizations for economic data, he was also a spy. There are some very cool books about his life. So even if you don't like data visualization, look him up. William Playfair, he's the man who got us the line, the bar, and the pie chart. Okay, so but why do we visualize data? So can't we simply do tables? And I every now and then in organizations encounter people that tell me a story that goes more or less like this. Leave all these pictures out, just give me the raw data like you see here, because I'm a number person. I don't like all these drawings. I just give me the number. Give me the Excel file. That's the next sentence they will express. And if we look at these 4 data sets, they're pretty straightforward. It's only 4 data sets. Each data set has 2 variables, X and Y. If you remember your statistics class, you probably get really far with the mean and variance and etc. But these 4 data sets are very similar. The differences are there, but it takes some time. Very little data set. However, if I turn this table into a chart, let's do that. Let's see if technology works. There you go. Then I think you need half a second to see the differences between these 4 data sets. By the way, I'm not saying that we should stop using tables. For me, a table is a very important data visualization as well, but a table does something different than a chart. A table is ideal for individual comparison. Look, 8.84, 7.71, 9.26. Those type of comparison, this kind of precision is impossible in any data visualization. But the good thing is, if you visualize the data in a graphical form, you lose some of this precision, but you gain the form, you gain the direction, you gain the shape. And again, the question is, what's your goal? And depending on your goal, you need to decide which one will work better. And a lot of times you need both. You probably need a form of a table for the precision, for the individual comparison, and you probably need some kind of visual form because, well, here it's only 10 rows in each data set, but a lot of times our data is a bit bigger. So why shouldn't we make use of this capacity that we all have as human beings, is to recognize these patterns. All right. Well, if we then move on, I already warned we need to do something about quantitative thinking. And here I have a definition with me. So the discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. Does anyone know which term belongs to this definition? See, no.
We don't know so much here, or at least I don't.
You're on mute, Tata. Sorry.
Sounds more like accounting.
Like a?
Accounting.
Accounting. All right, accounting. Well, they wish. No, it's not accounting, by the way. Actually, this is the definition of statistics. And I don't know if everybody liked it at school to follow statistics. I must admit it wasn't my favorite topic to study. But today, I really love it. And the thing is, statistics is all about working with data. And some basic statistic knowledge is required to work sensible with data. If you don't have any statistical knowledge, it's very difficult. And again, in the training, I take on a couple of the basic concepts to learn people about. And one of the things is an example is that most of the time we visualize data, we want to visualize a certain relationship in data. It's all about relations. But there are only a limited number of these relations in data. Wouldn't it be great if we learn to recognize these? To give you an idea, I'm going to show you the 8 main quantitative relationships in data. And the first one is nominal comparison. And nominal comparison is a simple comparison of values for a set of unordered items. So these are products, departments, all these kind of things, services. And you probably have a numeric variable that you want to compare. As you can see here, you see here this column or bar chart. Probably a bar chart would work very good. But as we can see later on in the training, it's not the only way we can do that. So there's multiple forms to do this and to make this work. Obviously, if you do nominal comparison, you also need to do the time series. I think these are the 2 working horses in data visualization. And the time series, well, is that you want to see how something developed over time. What's this change through time? The next is ranking. You like to see which one is bigger, which one is smaller. You're probably going to order them ascending or descending. Part to whole is another relationship typically we want to see. So we have the whole, which we call 100%, and we want to see how big is each of the parts or the proportions of that whole. These 4, and as said, these 3 were clearly introduced by this Scottish friend. But the ranking is basically also a lot of times a bar chart. These 4 I encounter every day. A lot of times the next 4 are not seen as often, but it's not like we shouldn't. A lot of times people actually want that one, but they simply don't know how to do it. And the first one is deviation. I see a lot of times that charts contain 2 components, like an expectation or a target line, and an actual line, and then the audience needs to calculate the difference. which a lot of times is an impossible mission. So why wouldn't you make it direct? Why wouldn't you show the difference? Deviation, typical relationship. We see a lot of times in a lot of questions on data, but I don't see it very often resulting in the right visualization. Then we get a bit more technical, correlation. For the people that don't remember anymore what that was meant, this is basically the relationship between two numeric variables. So if you, for instance, have age and income, those are two numbers. Well, you put them each on one of the axes, and then you get this kind of scatter plot, and you can see if there's a relationship between these two numbers. And in this example, since all these dots are more or less on a straight line, we call this a correlation or relation between two numeric variables. Distribution is then the next one that we absolutely need to do. And the last one, although often asked for, not always for the right reasons, geospatial. Can I have maps? Can I have maps? By the way, maps is a very strong form to visualize on, but it's also a very complex one. Geospatial visualization is the most complex one, and I'll tell you why. Because in a lot of the other visualizations, we use the 2D position to give meaning. So the fact that this bar is here and this bar is there and this bar is there, maybe means that this is product A and this is B and this is C. So the physical location on my chart actually has a meaning. The moment I introduce maps, it's gone. I can no longer use the physical location because the map already makes use of that. So basically, you're limited in your options. Maps is a very complex one. But again, these 8 are the main relationships we can find in data. And these 8 are also a very good starting point to start selecting which chart works best. As said, we need to talk about human perception. So let's switch gear. Let's leave statistics behind and let's go for human perception. And on the human perception, there's a couple of things that we need to address there. First of all, we see with our brains. Some people say, no, I see with my eyes. Yeah, well, the light comes in through your eyes, but then the interesting part starts. Then we need to address some very specific things like pre-attentive attributes. These are attributes in our surroundings that we don't have to think about, that we don't have to actually start thinking about before we can use them. These are the attributes in our surroundings that make sure that we are still alive today. These are the ones that some people call this the instinct. We also have Gestalt. About 100 years ago, introduced by some German scientists, psychologists. They wanted to know, why do we see the forest instead of the individual trees? So why do we see the pattern and not the individual components? And those are the Gestalt principles. And obviously in data visualization, these play a very important role. And so we need to talk about them. And finally, on human perception, we need to talk about system 1 and system 2. This is based on a very interesting book by Mr. Kahneman, Thinking Fast, Thinking Slow, where he explains that our brain basically have 2 systems. And not both of these systems are well suited for data visualization. Only one of them. So we need to make sure that we always use the right one. So again, as said, we see with our brains, because basically what happens is that light comes into our eye, and at the back of our eye, that light is transformed into an electric signal that goes through our optic nerve all the way to the back of our head. And here at the back of our head, we have the visual cortex. And the visual cortex actually is like a control tower that makes the decision, okay, can I process this piece of information? Can I do it myself? Or do I need additional parts of the brain to help me out? And the funny thing is that if it's something that the visual cortex can do by himself, we call this fast. Everything in brain is fast. That's all microseconds. But again, the visual cortex is really fast. The moment the visual cortex needs help from other parts of the brain, we call it slow. So a question, maybe Yolanda, maybe you can help me out. Do you know how often in each day, each 24 hours, it becomes dark?
How often it becomes dark?
Mm-hmm.
In general, one time, I think.
Okay, in general, one time.
Unless there's a solar eclipse or something, but.
Okay. Well, sorry, but I'm going to disappoint you. In general, it's 20,000 times a day, every time you blink with your eyes.
Okay.
And but you know, the thing there is that we don't notice that. Yeah, right now, and right now everybody is taking notice of blinking of eyes, etc. But believe me, in 5 minutes you forgot about it again, and everything works normal. But the blinking of an eye, the fact that the microsecond that there is no light that actually gets into the system, is filtered out by the visual cortex, and that's what we call fast. And so that 20,000 times a day, this is eliminated, and we have a feeling like we are seeing our surroundings like it is. But actually, it's a manipulated image. Or like I say, like to say in the training, and again, I'm not going to show you all the examples there, but basically we're hallucinating all day. Yeah, we think we are perceiving the environment, but most of the things that we see through our eyes is actually a history. It's actually a construct that is built in our brains.
It's a little bit like you don't see your own nose, right?
Oh my
Because
God.
it's also filtered out by the brain.
Yeah, there you go. There you go. Yeah. Now everybody start looking at their nose. Absolutely. And the thing is that you might have also heard it. We have this phenomena which is called change blindness. Sometimes you see it also on the internet that there's two pictures and they swap all the time, and a very important part of the picture disappears every time, but we don't see it. So you see, for instance, a close-up picture of a plane, and the engine of the plane disappears, but we don't notice it because we are, let's say, we are not paying attention enough. We can't pay attention to everything, and therefore, yeah, we don't see it all. So that's something that we need to see, because how does attention work? If we don't know how attention works, how do we know which part of our report or dashboard is going to be seen or not? And then after we dive into more detail about how this system works, we also need to translate this into what does it mean for visualization itself. And then there's all kind of lists out there which basically say which components work better than others. And everything that you place on a 2D position in a plane on a single scale is something that we can really analyze very well. So this is, for us human beings, the easiest way to estimate how big the number is we're trying to visualize by a bar, a dot, or a line. If it's on a singular scale, so if the scale for all the objects in the chart is the same, then we are good to go. But sometimes you also see some visuals like the stacked bar or the waterfall chart. These are using basically separate scales, because every component you stack on top of each other starts at a different level, and therefore they have their own scale. And then our precision goes away. It's more difficult to do precision in non-aligned scales like the stack bar there. But length is also a very strong one. So we are very good as human beings to evaluate length of a line. And sometimes we call this a bar, but in essence, and length is something we are really good at. Next, you can talk about direction or slope. Obviously, one of the components that you also use in a pie chart or in a slope chart, like you see here on the left. Next, we can also use width. We can make a line broader or thinner, depending on a value. So width is also something we can use for expressing visual data. And area, obviously. I think we have all seen all these maps coming by in the last couple of years with the pandemic and how many cases were. And a lot of times you saw small circles for small amounts and large circles for large amounts. And you can also do this with shading and saturation. A lot of times we use these maps where darker color means higher value, lighter color means lower value. And the order in which I put these elements here is actually that the top ones are pretty accurate, not as accurate as a table, but they're pretty accurate. And the ones at the bottom, they are less accurate, they are approximate. Again, not every visualization should be accurate, but at least should be as accurate as possible. So if accuracy is an important feature of the question you get, you probably need to select one of the items at the top. But if accuracy is not that important, you might be able to have a less accurate element being used. But it also has some other nice features. So the fact that we recognize a map is also very interesting to see. So are the neighbors also affected by what we're doing right now? Those kind of questions, a map can really well answer us, but the precision is gone. I can't see if it's a 1 or a 2 score. That's the consequence. Okay, and then I've created 4 visualizations based on the same data. So you see on the left, top left, you see a table. Then you see here a bit funny looking bar chart. That is called a lipstick chart. So you see these 2 bars in front of each other. One of the bars expresses our expenses and the other the budget that relates to it. Then here we have a deviation chart, which shows the difference between what we have spent and what our budget was saying in 2021. And here you see the deviation chart in US dollars. So not in percentage, but in absolute numbers. Okay. Well, a question to you guys again. If you see these 4 elements, and let's say that we call this one A, and we call this one B, and this one C, and this one D, maybe you can do it in the chat. So could you tell me which one you prefer? So which of these 4 visualizations, the data is the same in all of 4. Which one would you prefer? Which one is the best way to visualize this data?
C.
Tell me, Tato, why C?
Because percentage is highly relatable.
Okay. Okay. And I saw that the Maurits said B.
Yeah, so I think that B is, you can see the variation, while at the same time it's more exact, I think.
Okay.
Personally.
And I saw that Yolanda said it depends. And so my question would be, Yolanda, are you a consultant?
Yes.
All right, cool. It depends. But actually, you're absolutely right with it depends. The thing there is, if you only have data, there is no way you can decide which one is best. So sorry for tricking you into these answers. There is no right or wrong here. Basically, you first need to know which question was asked to determine which visualization works best. So if you would be, I don't know, the finance director, and you're going to meet each of the regions one by one, and you're going to be talking about the exact numbers, then probably the table would be good enough. Then again, if you want to see which of the regions has the highest expense, and then how they're doing compared to, then probably this chart would be best. If you want to know who is sticking best to their budgets, then probably the percentage deviation is interesting. But if it's okay, but where does our money go? Then probably the last one would be better. You see? So without knowing what the question is you're answering, there is no way to select the right chart or the right visualization. The technology providers make us believe that there is a way. Yeah? You see more and more of these software packages that they are suggesting which chart would be best for you to use. That's an impossible mission because technology doesn't know the question. They only know the data they have at hand. So we first need to dive into what is the question and how can we best answer it before we do anything else. Sorry for tricking you into this one. Okay, then after we have been looking at human perception, we need to go to visualizing data. And obviously the decision there, do we need a table? Do we need a chart? A lot of times I see people using charts where a table might be a better fit. And a lot of times that means that they fill the chart with labels. Have you seen them, these line charts, and every measure has the number in there as well? Most of the time you end up with a worthless table and a worthless chart combined. Tables and charts are very good at what they do, but combining them is in most cases not a good decision. So that's what we're going to look at. As said in the exercise we just did, we need to start with the why question. Why do we build these reports, or why do we build these dashboards? in the end, every report, every dashboard is the answer to one or multiple questions. And if we don't know the question, what's the value of the answer? I'm for sure you see a lot of organizations, and most organizations don't have a lack of reports or a lack of dashboards. They're everywhere. Yeah. And every time I come into a new organization, I'm this nasty guy who starts asking, oh, well, why did we build this thing? And in general, then everybody stops talking. Oh, I don't know. Somebody came by on Friday afternoon and they wanted to have it by Monday, so we build it. How can you build it if you don't even know what we're trying to answer? How do you do that without knowing the question? Well, we did. Yes. Okay, clear. Yeah, so this is what we're going to focus on as well. And then we're also going to introduce a model called charts. As you can see, there's no A in it, and the T is twice. This is not a typo, by the way. It is intentional. Because charts with one T is actually a model I borrowed from a guy called Andy Kirk. Andy Kirk is an author and a researcher from the UK, and he built this model to categorize different types of visualization. He only has one T, temporal, but since I think that the table needs a special place because it also has a lot of things that we need to think about, I've added the extra T. So if you look in the books of Andy, you'll only see one T, and I've added this additional T because the table really deserves a special place in this model. And then in the training, we'll go through all these categories and what are the typical charts that you'll encounter. And I've made a subset of it. So let's have a look at the C and the H for today. And because categorical, this is a very typical operation we do. And as you can already see in the icons, probably column and bar charts. Officially, this thing is called a column chart, and this thing is called a bar chart. I think those are the ones that we most often see. Lots of people using, some people also, oh, these are the boring ones. Yeah, okay, they might be a bit boring, but then again, as you might remember from visual perception, we are really good at evaluating length in a common scale. So besides that you might not like them because they're boring, but we as human beings are actually very good at deciphering these things. So let's not throw them away just now. And if you talk about bar charts, you can also stack them. And when you stack them, the function is not always ideal, but again, you can do that. If you don't want your bars to be so present, but that's the tendency that bars and column charts have. They're really in your face. You could even look at some alternatives. Here you see, we call this the lollipop chart. You can, I think, imagine why we call this a lollipop chart. It's a bit lighter than the original bar chart. Or if you want to emphasize the difference between two values, you can also use the dumbbell chart. It looks a bit like a small dumbbell, where you actually have these two markers and you connect them with a line. Or like we already saw in the example just now, you can also put two series in front of each other. In general, the front series, the dark blue bar here, is most of the time the most important one. So in this case, it's the most current element. And then the light blue bar, the one that's behind, is a reference value. In this case, previous year could also be the budget, like we saw before. But also, when you compare categories, there are some little bit more sophisticated charts. What you see here on the left bottom corner is what we call a bullet graph. Initially developed by a guy called Stephen Few, and actually as an alternative to the gauge. You might wonder, why is the gauge then not there? Well, the gauge is a horrible data visualization. A lot of people love them because it looks fancy, but it's a horrible thing to read data. And therefore, this guy, Stephen Few, developed the bullet graph, and that's the one. It's basically a bar chart with a target line in there, but very sophisticated, very cool thing to do. And most of the software packages nowadays have it, including Excel. You can also build them in Excel. And then last one I would like to do in this family of categorical is the waterfall chart. So you start with a certain level, and then you go down, and then you go up again. And well, in this case, it goes up and down all the time, but it doesn't always have to be like this. And again, as you can imagine, since now the scales are not aligned anymore, it's a bit less precise than we saw with the other ones. But again, it's still very useful. And as you can imagine, this is just a subset. There's so many of them, and we go through them and we talk about which ones work best in which situation. Let's also have a look at hierarchical. And in hierarchical, obviously, when we talk about part to whole, we need to talk about pie charts. Huh? I don't know if you've ever heard about it, but some people say you should never, ever use pie charts. Have you ever heard of that? Don't use pie charts. Actually, the same guy that invented these bullet graphs, Stephen Fuel, he's actually probably the reason why some people say never, ever use pie charts, because he always wrote the following sentence: save the pies for dessert. He basically meant, I only accept a pie if I can eat it. And let's say his criticism is rightful. Huh? So he's criticizing the pie chart because we are, as human beings, not really good, well equipped to evaluate these surfaces, these changing surfaces in a round shape. We're horrible at it. And if you make it a donut, it doesn't get any better. But for some reason, we really like these things. Huh? They're very popular. Both the donut and the pie chart are really popular. Again, in the training, we go to look in more detail what's wrong with them, but we also see that there is use for them, although very limited, I must say. I hardly ever use them. I think a lot of times these are misused. They are used too often because, I don't know, people like these round shapes and very colorful in general, etc. Hey, part to whole, you can also do it like this. Huh? This is called a waffle chart. Great name, huh? I don't know what it is with these part to whole relationship, but suddenly everything has to do with food. Huh? Pies, donuts, waffles. And it's not the best food to eat. Huh? So, but also maybe you don't see this one every day, but this is what we call a tree map. It's a square, but it's a tree map. Basically, divide thing. It's a squared pie, basically. And still the surface expresses a certain value. So the bigger the area, the bigger a certain numeric value is. Or maybe you can even go for a proportional symbol map. What you see here, you basically use a symbol, in this case a square, and depending on a numeric value, you make the square bigger or smaller. That's the basic idea. Or in general, and you probably are very familiar with this one, you can have a stacked bar chart, 100% stacked bar. You divide the whole thing and then you can visualize it like this.
And
Last
Michels.
question. Oh.
Yeah, me too. Sorry. Go ahead, Jolanda.
In my AI trainings, I use the Venn diagram. Is that also, I think that's also hierarchical or not?
Yes. You mean that you have an item that builds up into 3 items below? You mean like that? And then this one goes like this?
No, actually what I mean is, for example, in the Venn diagram, you can have a square or it can be a circle, which is 100%. And then if something is only 20%, for example, it's like a pie chart, but it's not divided into pies, but in a square. And then with circles in it or squares in it that show
3 overlapping circles, basically.
Yeah.
Oh, wait a minute. You say, okay, now I know what you mean.
Yeah.
Something like this?
Yeah.
Okay. Yeah. But, okay, and is each circle, the size of each circle depending on a numeric variable?
Yeah, absolutely.
And what's the meaning then of the overlap?
No, sometimes there is an overlap. There is not always an overlap.
Okay. I would say if there's no overlap, it feels like a proportional symbol map. Eh? So here it's with squares, but you can also do it with circles. Yeah.
Then for example, in this example, where there is apples, there would be written fruit. And then pears would be inside the fruit square and grapes would be inside like that.
Yeah. Okay. So you might have something like this or in circles indeed. Eh? So you have a apples and a pears and a grapes.
Yes, correct.
Something like this. Yeah.
Like that. Yeah.
Okay. No, and then that falls in the same family. Yeah.
I misused this time for my own benefit. So maybe, you didn't give the answer, but are these ones in the sense, so you didn't say why the circle diagram is bad, why is it bad, but are then the proportional diagrams or the tree line, are the other options within the hierarchical category better than the circle diagram or not? Or you say it's all to be avoided?
No. The thing there is, Maurits, is that so to look at the pie chart, basically a pie chart with a maximum of 4 pieces is doable. but it's very rough. It's never precise. And one of the basic criticisms is that we as human beings are horrible at evaluating round surface. Yeah, how big is it? And if we then take pieces out of it, we don't get any better at it. So it's a very imprecise way of displaying data. Yeah. The alternative that people like Stephen Few suggest is saying, you know what? Let me see if I've got some white space to draw it. Why don't we make it a bar chart with 4 bars in this case? Yeah. We are better at evaluating the length of a bar than we are evaluating a round shape with a piece out of it. Yeah. So he has a point there. The bar chart is a better, more precise way. But there is a but. You can already hear I'm going through the but. And the but here is that most people associate this form with the bar to whole. Everybody understands, oh, wait a minute. We have 100% and we have divided into pieces. And this concept of bar to whole is really strong with a pie chart, but the concept is not really strong with a bar chart. So the question there is, yes, it's not very precise, but should I ignore it always? I think there's room for the pie chart as well, because it's so strong at showing this concept. But there's one thing, a pie chart by itself can be acceptable. Multiple pie charts that need to be compared, forget about it. We are horrible at that. So if you say, I have a pie chart with the bar to whole for 2019 and a pie chart for 2020, and you let your audience compare it, it's not going to fly. Impossible mission.
Thanks, good insights. Yeah, thanks.
I know a training you might be able to attend, Marit.
Yeah, I'm tempted. Thanks.
Okay. Let me see, because I'm running out of time. Obviously, when we have identified all the different charts, we're going to look at the design of them. And like you see on this quote, a lot of time it's taking things off. Best design is not by putting more things on it. In general, it's taking things off until you find out you've actually removed something that was essential, and then you need to do one step back. So in this chapter, we're going to look at that. And obviously, the charts model will come back because we're going to look at individual chart types and how do we do it and how do we style them? How do you use titles? What do you do with those kind of things, etc. And hey, one visual is cool, but what about making a composition of multiple visuals? And then we call it a management dashboard. Wouldn't it be great? There's a lot of rules there, especially when we talk about layout. How do you put things together? So it's not like every position on a dashboard is the same value. Same like with stores. Not every store location has the same value. Well, we need to think about it. What is better? What's worse? How do we do that? Color is a very important one there. Color is one of the most important things we have in our toolbox to make our visuals work, but it's also the element that a lot of people overuse. If there's one thing that most people need to change in their reports and dashboards is limit the number of colors. There's so many colors, everything shouts at you. Some people say, yeah, but I like all these vibrant colors. Yeah, but it's not a question about what you like. We're not building visualizations because you like to look at the picture. Now we're building visualizations so people can learn something. And too many colors basically prohibits people from learning from their data. It's a shame. So we should be very careful. Color is very powerful, comes with a large responsibility. And then also we need to talk about visual hierarchy. Some things are more important than others. The things that move with the data, so the bars in your bar chart, the lines in the line chart, or the pieces in a pie chart, those are the principal elements. You need to make sure that they stand out. And everything else that is secondary needs to go back, needs to go to the background. You might not be able to remove them all. You need some context, but you don't have to keep them all there. And then we also need to go to this topic, explore to explain. And let me briefly show you what I mean with explore to explain. If you analyze data, we call this the explore phase. In general, it's people that know a lot about data that go into these databases or files and they look around and they find very interesting things and then say, oh, wait a minute, look what I found. Here's the insight. Great. But this is half of the work, because now there is this audience who in general has a very large distance to the data, and they also need to understand it. They might be the ones that need to make the decision. And then the question is, who is going to do the explain phase? A lot of time, it's the same person that did the explore phase, which is not always a good idea. It can be done by the same person, by the way, but at least there should be some discussion. And I'll tell you why the discussion is needed. Explain phase is all about communication. And communication is something you can hardly ever do by yourself. And you always need to check with other people if your intent, your message comes across. So if you then look at these two phases, the goal of the explore phase is to understand the data, where the goal of the explain phase is to communicate your findings. This is a completely different goal. There's nothing to do one with the other. If you look at the audience, a lot of time in the explore phase, the analysis is, the audience is yourself, or maybe a couple of your colleagues with you, where the explain phase is where you're going to explain it to other people who are way further away from the data. I always find it fascinating that sometimes people use like a pivot table in Excel to analyze, and then they have the opportunity to present these findings, and they use the same pivot table again for an audience. Believe me, in general, if you use a pivot table to present your data, you'll lose half your audience in 2 seconds. Because by the time you click, everything changes, and most of the people in the room are thinking, oh my God, what happened just there? So this is something different. We need to do other things there. Explore, people are very familiar with data, and the people that are attending these explain sessions, they are way less familiar with data. They might be more familiar with business processes and decision making, etc. But how do our processes translate to data? A lot of times they have no clue. So we need to be very careful with that. If you then look at where should the focus of the visualization tools lie? Well, in the explore phase, it's all about flexibility and speed. In your analysis, you see things, you want to react directly to it and go, mix things together, etc. Where in the explain phase, you don't need all this flexibility anymore. Then it's about simplicity, clarity, cohesion, one message. What's going on? What should we do? So the outcome, the narrative, there is no story in the explore phase. Where in the explain phase, you do have a story. You found what's going on. You know what has to happen. And therefore, the final goal of the explore phase is to find insights. And nothing's going wrong is also an insight. And the final goal of the explain phase is action. And these two need to be split out more. These are mixed together too often, and we need to be very careful to do that. So we need to spread them out more and make sure that we are sensitive by the fact that these people might not have the same background as we have when we are doing the analysis, and we need to be sensible for that difference. And that's communication, again, and you can't do it by yourself. This is something you need to do in a team, and this is something that we need to address also when we're looking at data visualizations. Because as said, the other day I was at an organization, and there was a guy who has built this very impressive report. Everybody, all his colleagues were agreeing, oh man, he's the king of the organization. He makes these really impressive reports. But the funny thing is, the only person that understood the reports was the same person. So everybody was really impressed, but they didn't have a clue what they were looking at. Then I think we are over-engineering some of our solutions, and we need to have a bit more focus on how do we explain, how do we get more people involved in that process. Okay. And then I want to do one last thing, and then I have to move to the second topic. As said in the beginning, this training has nothing to do with technology. So in the training, I literally use paper, pencil. That's the only technology that we generally apply. And it's also based on this idea. It's called the 5 design sheet methodology. You might ask yourself, why 5? I only see 3. Well, the middle one, the alternatives, is the one that you have to do 3 times. And so if you do this one 3 times, you have 5 sheets. Basically, if we want to build really good data visualizations, obviously we're going to do some brainstorming and exchange ideas, etc. I don't have to explain how that works. And then the idea is that for every question, we need to build 3 alternatives. And building literally means drawing. It doesn't have to be perfect. lot of people tell me, oh, but I don't know how to draw. Believe me, I'll show you some examples of my drawings. It's no rocket science. It's easy to do. And then you're going to discuss of each of those alternatives, what the pros and the cons are of each of these alternatives, to finally make a decision. How do you going to make your design? And again, if you do all this in paper, believe me, it gets better. Your biggest enemies in data visualization are, first of all, data. The moment you start diving into real data, we all know you get into problems with data quality and what have you. And the other challenge there is tooling. Oh, I've seen this new feature, or there's a new update, and before you know it, you're so into your tooling that you forget about, what was the question I needed to answer again? Believe me, using pencil and paper keeps you more focused on answering questions, and it allows you to put all these things that sound good in your brain onto paper. This is the first reality check that you do. And maybe I'm a strange person, well, I know for sure, but I know that a lot of times I have these things in my mind. I think, oh, this would be great in this form. And the moment I try build it, there's always these, oh, in my mind, it worked better. Believe me, if you do it on paper, you'll be confronted with these limitations sooner, and it really works. And to give you an example, I always take pictures of people in my training session, and these are some of the sketches they have been making lately. And again, this is not a production, but this is a way to put your ideas on paper and to have a sensible conversation with some colleagues about, would this be a good idea, before we jump into technology. And believe me, it gets better if you choose this approach. This is data visualization, guys. Bit over time, but I also want to make sure that I get time for the other topic. So while I get the other slides on, any questions so far?
Looks good. I like it. Yeah, nice. It's evident that I like it, but I really like it.
Thanks, Maurits. All right. So let's then shift gears, and because I only have, what is it, 3/4 of an hour to do the second one, data literacy. The reason why I started building on this training is that there were a lot of questions from people. Oh yeah, we're all being data driven, and what does that mean? And a lot of times I see that people, what it means for them is that they get some kind of fancy software on their system, and then we are supposed to become data driven. Okay, well, let me tell you, when I hear people saying we are data driven, I have this video in my mind, and I would like to share that video with you. I need to make sure that the sound is, let me see if the sound is shared. Is there?
Peter, come take a look at this.
Oh, sorry.
Mr. Daniels, look at this.
What's this? The numbers, they keep getting bigger and bigger.
The clicks are off the charts.
Yeah.
Yoshi, it's Walter. We're back.
Yes, sir.
I need more trees. More trees? I'll get you more trees.
Hey, take a look at wood pulp.
Everything you got on wood pulp right now.
He really loves that thing.
So guys, that's what I call data driven, you see? And I'll later on tell you that I also have another term for, well, I think a better term for data driven, but again, there's more to it. Huh? It's not as simple. Our structures that we have invented, our organizations are way too complex to simply say, okay, well, if a number changes, then we will change everything. It's in general, it's way more complex than that. Okay, well, so we need to work with data. That's clear. Huh? We need to work on that. And if you then look at it, so this is some research done, was a couple of years ago, with 9,000 employees. And they were asked, okay, well, do you think that data actually is an asset? And well, not surprising, 87% said, yeah, data are really important for me to do my job. I understand it. Yeah. But then the next question was, okay, but if you then need to make a decision, do you trust that decision and better when it's based on data? Well, hold on. Only 37% trust their decisions more when they use it on data. Oh my God. Okay, and then, okay, well, how confident are you then when you have to deal with data? And then only 21%. Shocking numbers. So apparently a lot of us find it very challenging to work with data. And again, we don't all have to be a data engineer or a data scientist, but we at least need to have some basic knowledge. If I look around my surroundings, not working with data, even if your job doesn't ask for it, is almost impossible. Data is being used everywhere, in the media, in your private life, and in your work, obviously. So yes, we can expect to hire some more experts, data scientists, data engineers, data, what have you, but that's never going to do it, is it? We need to make sure that the general audience gets a bit better at this. And then we really going to change something. So if we want to make sure that people know how to work with data, know what they can and can't do with it, then I think we are really making some steps. Then obviously the question is, well, what's the definition of this data literacy? And there are so many of them, and we found a couple of them, but this one was the one that resonated best. So it's our ability to read data. It's also the ability to work with it, to analyze it, and to argue with data. This is the one from MIT, and this is exactly also the building blocks of this training. So we're talking about how to read data. So when are you the consumer? How you are the receiving end of it? What if you're working with data? And again, the real work with data a lot of times is done by engineers, but wouldn't it be great if we can have a sensible conversation with them without having to learn all this techie stuff? But wouldn't it be great if we learn what these people actually do and how that impacts our data? And then analysis, obviously, yeah. I sometimes ask people, what is analysis? And then people say, well, I don't know, looking really concentrated at an Excel file. Okay, cool. Well, let's have a look at what analysis then is. And the last part, arguing with data. So can we have a story to tell? So here there's some overlap with data visualization that we talked about earlier on. And obviously you'll see some repetition there, but it's very little. So for who is this training? Well, basically for anyone, and in general, any professional that wants to make use of data. And here you have, well, the term I like more than data-driven is data-informed. I think data-driven, to me, gives me a feeling that the human part is cut out. And I think without the human part, data is a very tricky thing. So we are still the ones behind the wheel. So we need to make better informed decisions. And therefore, I like data-informed better than data-driven. But then again, I understand how marketing works. Data-driven will be the term. So I'll live with it. Okay, so then the agenda of the training, well, obviously, it's not going to be surprising. It's going to be these 4 components that we just mentioned. So, and we're also going to do them in exactly this order. So we always start with, how are you when you receive data, and how can you protect yourself from some misconceptions? How do you work with the data? How do you analyze it then? And how do you do it when you are the sending party? And when you look at the certification exam, because there's also an exam for this one, here the weight of the topics is more shared. It's exactly 25% for each of the topics. So you'll get for each topic the same amount of questions. And like you saw with data visualization, also here you'll get the slides, you get an exercise, you get the speaker notes, you get some tips. I'm a big fan of books, by the way. You might also notice it with the sources that are mentioned on the slides. We will also mention which books to read if you want to have more information, etc. That's all there for people that want to do the want to give the training. Also here we have a handout, and also we have this exam similar to what you've seen with data visualization, and it's the same number of questions, the same number of time, the same percentage to pass the exam. Okay.
Is this also a 2-day training?
Oh yes, a good question indeed. Yes, it's also a 2-day training. Yeah, so both trainings are a 2-day training. I don't know if you noticed, but I can talk weeks about the topics. But I also understand that I also need to respect that not everybody can make time for it. And therefore, we chose the 2-day time frame for both trainings because it gives enough time to share the fundamentals and to have people exercise with it without claiming too much time, because I also see that a lot of people find it difficult to find time in their busy agenda. So therefore, both of them are 2-day trainings, yes. But they could easily be expanded if you want to, but we have built them around the idea it needs to be, you need to be able to deliver them in 2 days, yeah.
What are you proposing for the days? 2 days after each other, or some time period between it?
Yeah, so I do both. The good thing about 2 days and next to each other, so one after the other, is that you can continue with that same group and the focus stays there, etc. The good thing about if you put a week in between, I wouldn't put more time, by the way, but you can put a week in between. You can actually then give maybe people some exercises they can do in their own time. Yeah, so call it homework. Maybe not the best thing to call it, but you can do some exercises in between, or people can maybe collect some examples from their own experiences, etc. So that's something you can do. But in general, I prefer to do it in a 2-day block, one after the other, because it gives a bit more focus. And it also saves a lot of time on the second session to repeat what did we do the first one. But again, that's a personal thing. But both work, yeah.
You would also, in this order then, first the visualization and then the literacy?
Oh, actually, both attract very different audiences in my experience. So data visualization in general is attended by people who actually build reports. Data literacy is a way broader audience. It's basically, for instance, I've been doing some training sessions in November for a municipality, and they basically wanted to have all their workers go through that training session because, well, who can say, oh, no, I don't know anything with data nowadays? That's impossible. So they wanted to have like a basic level of data understanding. So this training is way broader, the audience is way broader than the audience for the data visualization, because, well, not everybody builds data visualizations, basically. Yeah, that's I think it's a smaller group. Okay. If we then look at read data, what are the topics addressed there? Well, first of all, what is data? A lot of people are surprised by this question, but then it's very difficult to answer it. So I'd like to test this out with you guys right away. There's always a lot of data. So how do we summarize this? Lots of things go wrong when people start summarizing data. Then we look at examples where I take a lot of examples from the media where, well, people are confronted with some form of data. And then we're going to figure out, okay, well, what does it mean? What was the intention? How do I see it? And we end up with the data checklist. There's 8 questions you should ask every time you see data. So these are the 8 fundamental questions that will protect you from misunderstanding or maybe drawing wrong conclusions from your data. So it's the 8 data check questions that we do, and we also apply that to an exercise. But let's start with what is data? Who wants to have a go? What is data?
Yolanda, I think you should start.
Facts, statistics.
Sorry?
I was saying facts or, statistics.
Facts or statistics, yeah. And I like the term facts, by the way, Tato. So facts I like because it also relates to factual. I'm looking at facts from a non-technical perspective. It's a fact. Every now and then I come across people who tell me, Michel, we can discuss about opinions, but we can't discuss about data. Because data is hard and opinions are soft. Yeah. I find that horrible when people say that, because I'll tell you one thing. For me, data is as soft as an opinion. Data is biased by definition. And I'll tell you why I think like that. I always like to bring along this picture, because this picture actually tells me what data is for me. And data definitely is not reality. So you see here the reflection of this building, and you see this very nice curvature in the front of the building, but actually this building is built straight. There is no curvature. What happens here? Well, this actually is not the building itself. This is the reflection of the building. Data is not reality. Data is a reflection of reality, and therefore it's always limited. I don't see any colors here. So it's very limited. And second of all, it can change along the process. So it can change what we think we're looking at. So we need to be very careful. And then people say, but why is data then as soft as opinions? Well, the moment we collect data, we also make a decision to not collect other data. And the fact that you select a certain data to be collected and other data not, means there is a bias. And therefore, data by definition is always biased, and we should always ask the question, for which purpose was the data collected? And then we need to ask ourselves the question, is that purpose compatible with my purpose? And if you can't answer that, it's simply impossible to continue. So simply looking at a table in some kind of system, say, oh, great, these are the orders, let's take them in. It's not going to fly. You're probably going to find out that these are the orders, not exactly what you anticipated or whatsoever. So data itself, I see a lot of people say you simply need to gather data and everything will be fine. I don't believe that. Maybe I'm wrong, could well be, but I think we should be very critical there. So data needs to be checked very closely. What is the purpose? How was it collected? And then we can continue to do something with it. Okay. By the way, I looked for a very long time for a nice definition. And I found one. The only thing is, and I need your help, guys, I don't know what the source is. So if you find the source of this definition, let me know so I can write it down. I love this definition because this really helps. So what is data? Well, data describes a quality or a quantity of some object or event. And in this case, we human beings are also objects. Sorry for that. But so it describes a quality or a category, or a quantity, a measure, a big or small measure of an object or person or animal, or an event or a transaction. Very easy definition, works for me very well to apply in a lot of cases. So I like this definition very much. Yeah. And as said, if anyone finds the source of this sentence, let me know. And otherwise, I'll claim it. But I'm not sure. I found it somewhere, simply forgot to write it down. Okay, but let's have a look at why do we use data? Because, okay, well, so we have all this data. Why do we use it? Well, first of all, we use data to shed light on ourselves and our environment. It helps us to distinguish between truth and falsehood. And it enables us to choose the sensible courses of action. That's basically what we're trying to do. But data in itself alone is not enough. We need something more than just data. Data is just the raw material. And in most cases, digital form, not always, but in most cases, digital form. And so we can capture and encode facts, let's call them facts about the world. But the next step is obviously information. Then we have the data that's been organized and formatted so that we can use it in some way. And then the next step is knowledge, and you probably already know these pyramids, the DIKW pyramid: data, information, knowledge, and wisdom. And knowledge basically means that you take in information and you combine them with things you already know. So you incorporate it into a broader understanding of the world, where wisdom is applying knowledge. So this is the action part. Remember, we just spoke about it. Action is where the real value kicks in. Well, that's what we call here the wisdom. And if you then look at how it works, well, basically we collect data, we interpret it, and then it becomes information. We structure it in a certain way. Then we associate it with things we already know. So we put it into a broader perspective. And then finally, we apply it. We do something with it. And therefore, this is basically the reason why I struggle with data-driven decision making, because that suggests that you just start here, and then based on this, you can automatically do great stuff. But you ignore the fact that we also need these steps. And the higher you get into this pyramid, the more you get into the exclusive domain of us, human beings. So we are the link here between data and action, and that's us. We are still needed, and I think for a really long time. And obviously, you can automate really cool stuff, and you can build great models and whatsoever. But in the end, we are really good at this. There's no model yet that can beat us to it. So we can actually, so we need to play a role here. And therefore, I like this data-informed definition better, because we can't ignore the fact that we need some additional steps before we actually can do
I'm sorry,
something.
I just have to step out for a minute. There is a delivery at the door.
Okay. Okay, so let's dive into some data. Here I've got some unemployment figures, and these unemployment figures are from the Netherlands, but it doesn't matter. You can take any unemployment figure from any country for that sake. Question, guys, do you know how this number is calculated? Where does the unemployment figure come from?
So do you mean how it's represented on the sheet, or how it's generally calculated?
No, let's start with how is it calculated?
So I believe that the unemployment rate is the from the people that can and should work. So from the, let's say, everybody between 18 and 67, from those the people that actually take part of the workforce, from those people is the percentage of people that don't actually work.
Okay. So if I understand correctly, it's unemployed labor force divided by the total labor force, correct?
Yeah, that's what I believe.
Okay. Well, then Maurits, how do you know the number of people who are a member of the labor force in a country?
Let me, this is basic economy. So the labor force, bevolking, is, I think it's registered with a general agency of statistics, but besides that source,
Okay, but
I believe it's everybody that can or should work between the age of 18 and 67.
Yeah,
that's
I'll
not
get to
true,
the
because then you have
definition right
also the
away,
students.
Maurits. It's slightly different, but I'll get to that definition. Okay, yeah, obviously I get the numbers from Statistics Netherlands as well. So the Dutch Statistics Office provides me those numbers, but where do they get them from? How do they know if you are part of the labor force and I am part of the labor force?
From the tax office, I assume.
Okay, from the tax office, yeah, could well be. Unfortunately, that's not good enough. I'll tell you one thing, in practically every country in the world, there are a couple of exceptions, but in practically every country in the world, there is no such thing as a central administration that registers labor force or unemployment. It simply doesn't exist. Let's say it's not a question, or it's not a form that you fill in. The tax authority doesn't know either, by the way. So what do most countries do, or what do most statistics office do? They do a questionnaire. So here in the Netherlands, they do a questionnaire every month among 30,000 inhabitants of the Netherlands, and they ask them, do you work? And if you say yes, then okay, you have a job. If you say no, then they ask, are you available for work? Do you want to work? Can you work? And based on that, they calculate this figure. Yeah. So these numbers here, with 2 decimals in there, yeah, are actually the result of a questionnaire. So we are not measuring behavior, we are measuring opinions. It doesn't mean that the number becomes unusable, but the usage is, let's say, less than I anticipated. I always thought that this number was pretty hard. If I read the newspapers, they talk about it as if it's clear. Oh yeah, this is the number, and oh clear, we went up 2/10 or down 2/10, and we explain this by some kind of economic phenomena. But the strange thing is, this is a questionnaire, and the questionnaire is done in most countries amongst all people between 15, so not 18, 15 and 75 years old. And that's what we then call the labor force. Yeah, and the unemployment are the people that don't have a job but do want to work and are available to work and can work. The funny thing is, if you look at the technical descriptions of the statistics office anywhere, they in detail describe what you can and cannot do with these numbers. And the first thing they always say, these numbers can only be used for long-term projections. And long-term projections in statistics language or economics language means 5 years or longer. Eh? So specifying these numbers by month with 2 decimals is fooling yourself and anyone else. There's no sense in measuring it so often and then you can only use it for long-term projections. But what do we do with it? At least that's what I see in the news and in the newspapers. Every time this number goes up, oh my God, unemployment goes up. Every now and then, oh great, the unemployment goes down. You see, but in the end, it's a questionnaire. Who knew it was a questionnaire? Ooh,
Astonishing.
lots.
I was aware that
Astonishing, eh?
television rating is also based on a questionnaire, which is also surprisingly, but I know that
Yes.
TV ratings are based on it.
Yes. And again, it doesn't mean that the number is not usable. It's simply not as usable as I thought it was. And I think, therefore, we need to be very careful. Whatever data we use also in our organizations, we need to first understand where does it come from, why do we collect it, and how do we collect it? Because that has a lot of meaning. Instead of simply saying, oh, I'll go to the statistics office and I'll get the numbers and, oh yeah, unemployment is this. Oh, wait a minute.
Yeah.
Sorry, somebody wants to say something.
No, I believe it's also on inflation figures is based on the month before. So every month you hear this month it's 6%, this month it's 8%. You think, wow, last month was only 6, now it's 8, but it's actually compared to the year before. So it's not a cumulative figure.
Yeah.
But if you hear it emotionally, you respond like, oh no, it's another. It's still big. It keeps growing. Yeah.
There you go. There you go. And I think if we want to make use of the data, we should be a bit more sensible to what it means and what it doesn't mean. Huh? So that's the idea. One other thing, when we consume data, do you know the guy here on the right? Very nice painting. So the guy on the right, do you know who he is? No? The guy here on the right is Napoleon Bonaparte, French emperor, remember him? And the guy on the left actually is the British Prime Minister, William Pitt. And William Pitt is clearly less famous than Napoleon. But a lot of times when I ask people about Napoleon and I ask them to associate, what do you know about Napoleon besides he's French and emperor and always had his hand in his jacket and those kind of things? A lot of people also say that he was a small guy, that he was short. And actually, if you look at it, this was the way how they measured it in France in the days he was there. And again, my French is not really well, but it says 5 pieds 2 pommes. 5 feet 2 inches, I believe, is the English translation. And if I translate that to the metric system, nowadays that guy would be 1 meter 57 centimeters. So that's not the biggest guy, clear. But now there's a problem because Napoleon wasn't 157, he was actually 168. So what happened? Well, in the days of Napoleon, both the English and the French had a similar way of writing length, but they meant a different length with it. So the imperial inch, the English inch, was shorter than the French inch. So the fact that we are still talking about Napoleon was a small guy is all part of English propaganda. Yeah, because the English, here you see the painting, actually James Gilray, who painted this, was one of the causes. They wanted to show Napoleon as this little brat that was taking everything he could. Literally, he's taking the whole of Europe, you see. He's so small, he can't even sit on his chair. He's standing in front of it. They simply wanted to put Napoleon as a small man, but he wasn't small, especially if you know that the average height of a male in those days was 165. So he was an average height person in those days. But we still associate him with small. The reason why I bring Napoleon to the table is that if something is not true, but you repeat it very often, you run the risk that it becomes true. And this is a very good example of it. A lot of us think Napoleon as a small guy, and it was simply because of this image and the fact that that they messed up these different measure systems and thought that the imperial inch was the same as the French inch, which wasn't. So let's be careful with expressing data in the wrong way, because before you know it, it gets repeated and repeated, and people start thinking they are true. And I see a lot of these examples also in organizations. There's always these magical numbers in organizations, the number of customers, the number of churned products, I don't know, whatever metric. And these start living their own life, and nobody ever checks whether they're true or not. And then before you know it, you're going in the wrong way. So that's for reading data. Let's shift gear, because I see I only have 20 minutes left. And work with data is a bit more technical. So we need to think about how is data created? Where does it come from? Data quality, very interesting topic. I don't know about you, but if I hear data combined with quality, in general, it's bad news. I've never heard anyone say, oh, data quality is great. With us, it's great. So we need to have a chat about that. And then we need to know, how do you acquire and how do you clean data? And also, how do you manage it? Very important topics to address there. And I'd like to show you a little example. This is actually based on a book I got from the Dutch Statistics Office. In general, all our statistics office, they are world champions in collecting data. And wouldn't it be great if we would learn from them how they do it? And in this book, they actually describe it. They say, you know what? Every time we get data from outside, we call this raw data. This is data that we get from anyone, and we don't have any impact on it. We simply need to live with how it comes. Raw data, that's how they call it. But now they need to process the data to make it useful. And the first step they do is they go from raw data to what they call input data. And input data, as they say, is making the data technical readable. So you need to make sure you get into a file type that you can read. Sometimes this feels like that's easy, but it sometimes can really be complex. And then you need to make sure that your strings, your numbers, and your dates are normalized, that they all have the same format. You might have seen it, that sometimes if you have strings in a file, that there's all these strange characters in there. Sometimes this is caused by incorrect converting of files, something that we need to normalize, but also numeric normalization. Do you use a decimal point or a decimal comma? Do you have really large numbers that you specify in a different way? And date normalization, really interesting. In Europe, we do day, month, year. In the US, they do month, day, year. And the ISO standard is year, month, day. So you already have 3 different types. And if you mix them up, believe me, life gets really complex. So you need to make a decision. What do you do and how do you make it work? And then you have input data. And the funny thing is, this step is something you can really easily automate or do it with very little human intervention. This is an easy step to do. And now we go from input data to valid data. And valid data is the data that they use for analysis. So nobody does anything until it's called valid data. And in valid data, then you need to know what you're looking at. What do we do with missing values? I'm really fascinated by the concept of empty values. What does that mean? People forgot about it? They didn't know it? What's going on? But also implausible values. I've got a person here with a driving license and they're only 5 years old. That's probably implausible value, and definitely an implausible combination. And in the end, what you also need to make sure is that your data gets into a structure that makes it easier to do analysis. And the funny thing is, all software products out there that help you do data analysis, they're all in love with one single data structure. Wouldn't it be great if we would all apply that same structure? Life becomes easier. In practice, I see people do all kinds of stuff. They just do something, while they should have known that all software packages, and I'm talking from Excel to R, Python, and everything in between, they all love the same data structure. You're probably now wondering, which one is that? Well, I brought this friend with me, Hadley Wickham. He is a professor of statistics at the University of Auckland and also at Stanford University. And he talks about this format as tidy data. And as he says here, tidy data sets are all alike, but every messy data set is messy in its own way. You might not have heard about tidy data yet, but for the people that are a bit more technical, tidy data is the same thing as a star schema, as a third normal form data structure. And the funny thing is, if you put your data in a real star schema, all your analysis software will work like a charm. Any other scheme, by the way, is looking for troubles. Huh? So you simply need everything into a star schema and you'll be good to go for your analysis. The best way to do it. Then I would like to also show you something about management. Managing data, because a lot of times I see that I see these expressions of data similar to what I see here. So for instance, okay, we had a nice number of likes, and look at it, 8.7% higher than last month. Wow. Yeah, let's get the drinks out, huh? But hey, maybe another month or the same month I get a different message if I see this, huh? Oh my God. 8.7% down. This is not good, huh? Well, both these expressions, probably the left one you like better than the right one, if you want to have more likes, obviously. But the funny thing is that both of these data expressions or dashboard components are horrible. And I'll tell you why they're horrible. Because what you're actually doing here is comparing 2 points with each other. You're having your result of this month, and you're comparing it with the result of last month. And basically, you're making a lot of assumptions about last month. You're making an assumption that last month was normal. Because if last month was the best ever, it was all records were broken last month, then this message is not a problem, is it? Oh, no, we had the biggest number of likes ever. And yeah, now we went down 8.7%. Oh, then nothing is going on. But we do see this red signal on our dashboard. Or if last month was the worst month ever, then this says green, but actually it's not something to be bragging about. So unfortunately, these point comparisons are lousy comparisons to learn something from data. And it's not because I'd say so. The thing is, it's already clear for ages that point comparisons is only measuring noise. It's only measuring and therefore managing your environment on noise, not on signals. Every variable that you measure is composed out of two things, noise and signals. And we don't want to see noise. Noise is random. Noise cannot be explained. So let's skip the noise. I only want to see the signals. Well, for ages, we had all kinds of techniques to split out noise and signals, but for some strange reason, we're not using it. For instance, this is how the data looked like. You see? So yes, we went down 8.7%, but hey, last month was really, really exciting. So nothing is going on. You see, we are on a good track. Okay, we had a little down this month, but again, there's nothing really going wrong. So how can we split signals and noise? How can we ignore noise and focus on signals? Well, the people that are Lean Six Sigma, they have this approach for it, and they called process control charts or XMR charts. Sounds really fancy, but it's really easy. Basically, what you do is based on some historical data, in general 5 data points, you calculate a central line, and you calculate an upper and a lower control limit. And the basic mechanism is as follows. Every time you go outside of one of the limits, something really strange is going on. In other words, the chance that this happens is so small, you need to have a look. So this is a way to identify real signals and ignore all this noise in the middle. Because in general, I see a lot of people say, oh, we went up, great, let's have a party. Oh, no, we went down again. Oh, we went up, we went down. You see? And this is all noise. All these changes are normal behavior of the variable. And if you use these charts, and you can use them in any tool you like, from Excel to anything else, it's really basic statistics. I don't even know the formulas, but I know where to find them. And what you then can do is that if something falls outside of these boundaries, we call this a special case, it means something really special is going on. You need to investigate what went here. Maybe we had a breakdown, we had a power loss or whatsoever. Okay, then that maybe explains this single point. But there's also a couple of other patterns that we need to have a look at. The long-term pattern, when each point, 8 points, sorry, not each point, 8 points in a row are on the same side of the central line. So the central line is here in the middle. So all these 8 are all on top of the central line. And then we call this a signal. And this is also a signal. It's a really small chance it actually happens. It's 0.39%. Eh? So less than 0.5% chance that this actually happens. And if it happens, you know something really has changed. Your system or your process you're measuring has really seen an increase in this case. So this is the time you're going to recalculate your central line, and probably it will be higher, and you take it from there. Or there's another one called the short term. 3 or 3 out of 4 in a row are closer to one of the limits. This is also a reason to recalculate your central line. And there you go. This is managing your data and looking at data and measuring real signals and ignoring noise. Unfortunately, I see a lot of popular approaches simply reacting to any change in your data, month-to-month comparisons, and they're basically nonsense. And our friends from statistics already know that. We simply forgot to ask them how this works. Okay. Hey, I see. I have very little time left, so I'm going to speed up a bit, unfortunately. Again, if you talk about analysis, data analysis, we need to talk about a couple of things. Obviously, about types of analysis and how to do it. But more importantly, since analysis a lot of time is done by humans, we need to talk about expectations and thinking shortcuts. We human beings are really good at these things. So in this component, we are going to look up the most obvious ones. And one of those obvious ones, and you maybe are all aware of them, is called confirmation bias. Huh? This guy, by the way, you see on the picture is called Warren Buffett, very famous investor. And he says, well, what human being is best at doing is interpreting all new information so that prior conclusions remain intact. And let's be honest, we all suffer from this. None of us is immune to this. The only way to solve this is to make sure that you surround yourself by as diverse possible, so different people, and have open conversation about what do you think is going on here. Otherwise, you're going to be fooling yourself, and fooling yourself is not the best thing to do, is it? So let's be very careful. And again, in the training, we look a bit closer to confirmation bias, but also to some of these other very notorious biases. Okay, then argue with data. As I said, it again goes to explore to explain. It uses charts again, like we saw in the training on data visualization, and it goes a bit deeper into visual storytelling. To give you one example, and then I'll need to wrap up. Having the right data and presented in the right way is one of those key principles. And here you see I've got the revenue by month shown. So each month it's growing. And I also have the number of customers I have as an organization. And also this one is growing. So in this case, if I look at this data, I would say, wow, we're doing great. Both numbers are growing. It's excellent. Feeling nice. So at the end of the year, it's almost Christmas. I think we have done a great thing this year. Unfortunately, a lot of the messages in our data are not as clear like you see here. Because the question here would be, okay, so I have more customers and I have more revenue. But what happened with the revenue per customer? Well, let's calculate that one. Here you go. So as you can see, we started January off where $5,000 was the revenue per customer. And we ended this year with only $2,829 per customer. So yes, these two figures showed very nice increases, but they have their own independent axis. And therefore it's very difficult with these independent scales to determine what's the relation between these two. Here I calculated the relation. And now I must say I'm not as happy as I thought I was, because if my revenue per customer is going down this way, I need to check. And only seeing it like this is maybe not good enough. What about if I add some additional context? Let's say I add the past year to it. There you go. if this is the past year, I would say, oh, so apparently in the beginning of this year, something really special happened, and therefore the revenue per customer was so high. It looks like we are going back to quote unquote normal behavior. Okay, that's okay. But let's assume that the context was not looking like this, but it looked like this. Then we have a problem, eh? Then we can say, Houston, we have a problem. So as you can see, having the right raw material is not good enough. You also need to do one step further. You need to really think about what is the question I'm trying to answer, instead of only looking at, oh man, these nice charts, they're all going up, gives me good feeling, but actually I don't know what's going on there. Okay, I'm going to wrap up because I've got the last minutes. Data literacy is all based on 3 fundamental C's. The first C is curiosity. I know the saying, curiosity killed the cat, but it saved the data. You need to be curious all the way. You need to get to the bottom of where your data comes from, how it's organized, how it's collected, etc. Otherwise, it's very difficult to make it use. Also, you need to make sure that you stay creative. If you only ask why all the time, you become this nagging child. Believe me, you're not going to get any popularity prize with that. But let's be creative. Sometimes also with the data you're going to use. Maybe the data you have is not ideal, but it will get you more or less through what you want to do. So creativity absolutely is one. And the last one, let's not ignore it. Let's stay critical. Not cynical, by the way. Some people mistakenly compare this with cynicism. No, it's not cynicism, it's critical. Ask the question. We need to be able to ask the question, look at the bigger picture, and check these things. And I think if we can get this done, if we get more and more people to get into these 3 C's, then we will be able to do really cool stuff with data. And the last thing to wrap it up, this is my dream. I would like to hear this question more often. Do you have the data to back it up? And not only hear it being asked, but also that we are willing to give people the right answer. So if we really want to make data work, we need to learn something about what data is and what it isn't. Then hopefully I see myself, although this must be a really young version of me, sitting there in the sun on a mountain. But hey, I've got 2 minutes left. So how about time management? Any questions so far?
No, I don't have questions, but I want to give you a very big compliment because I really like the way you explain everything. And it sounds very interesting. Absolutely. I didn't know what to expect, but the way you explained it, the way your story is going, I like it a lot. So thank you for that.
You're welcome.
Yeah.
Yeah, I also have to say it was beyond my expectation, actually. I just thought that you'd give a very brief overview, but you've gone into a lot of detail, really making it clear what the programs are about. Thanks for that.
Okay, you're welcome.
Yeah, thanks, really good. And Yolanda, may I ask you, because you do a lot of training also on AI and such. To me, I think that before we all move to AI, these are actually like the data literacy is an essential training, I think, organization-wide trainees and such should do before they even start thinking in the direction of AI. What is your view on this?
Yeah, absolutely. Because AI obviously is based on data. So you should have an understanding of data and what it means. And also data visualization is very important because when you have the data, you understand what the data is, and then you will process it with AI, or AI will do its thing with it. Then you need to be able to communicate it, to present it to other people, because somebody has to be able to make sense of all the data that AI is coming up with. So I think they're very important basic understandings for working with AI. Plus, what I also really like, yes, I do a lot of AI trainings, and there is also some technical stuff in it, a lot of statistics and mathematics. But I always put emphasis on the human side, and that's what I saw here too, and that's probably why it resonated so well with me. Because it's true, we as humans still, I don't know for how long, but still we have a role in it, a very important role in it, and probably I think for a long time we will. And we have to be clear on what that role is. And that's what I'm also focusing on in my trainings. And with what Michel told us today, I also see that we can better understand what our role will be in the future if we have an understanding of what data is and what it means to us. So it's very good stuff.
No, thanks.
Yeah.
Thanks for the same. Okay, Michel, you have to change and go play tennis. So
The match started a minute ago, and I still need to go there.
thanks all for participating. I think the content is really good, and yeah, we'll try it again next year. There's already a lot of demand for it, so that's good. Usually it's the other way around. So let's see what it will bring in, what it will bring next year. Thanks all for participating. Best of the holiday season, and see you in the near future. Thank you, Michel, also.
Okay.
Hey, thanks, guys.
Thank you.
Bye-bye.
Bye. Thanks. Bye.
Bye.